All right, here we go. All right, going to look at the elimination method today. We looked at substitution method last week. Elimination method. Go ahead and jot down that system right there. Jot down that system. As you jot that down, I'll kind of refresh you a little bit. Remember, a system of equations, for your case right now, is just going to be two equations at one time, okay? Both equations do describe lines on a graph. So we are technically still looking for intersection points on a graph. Remember, intersection points equal solutions. We found, and we talked about last week, that the majority of the time, these two lines are going to intersect at one point, hence one solution, which was an ordered pair of numbers, an x and a y value. Okay? The other two scenarios that we looked at were parallel lines that never intersect. That means there's no solutions. And we looked at two equations that describe the same line, line on line, which was infinitely many solutions. So you either get one solution, no solutions, or infinitely many. Those were the three scenarios we had talked about. Okay? With this system here, you should notice that your x's, your y's, your equal signs, and your constant numbers all line up. Okay? Everything lines up pretty nice and neat. That is good. That's a good visual that the elimination method is probably going to be a pretty good way to go. Okay? And quite honestly, this method is probably the preferred method to use. Okay? Now, elimination method, the word eliminate, to make go away. For this method to work, what we need to do is we need to try to make sure that either the x's or the y's, we can get one of those to eliminate or go away. I want you guys to look at something, and this is a pretty ideal setup. I want you guys to look right here what I put in red. If you were to take negative y and positive y and add those together, what would you get? What would negative y plus y be? Okay, let me ask you this. Let me ask it a different way. What would negative 5 plus 5 equal? 0. So what does negative y plus y equal? 0. Okay? Right now, if we look at these y's, we have a negative y and a positive y. Those right now, if we combine those, will eliminate themselves. They cancel. So here's what we're going to do. We're going to draw a line right there. It's kind of like old-fashioned addition, subtraction. Okay, we're going to draw a line underneath both those equations. And we are just going to combine like terms. We already know that negative y plus y goes away. They eliminate, and that is good. Right here, what's 1x plus 3x? 4x. 1x plus 3x is 4x. So we're looking up and down here. We're combining like terms. 1x and 3x is 4x. Negative y plus y, gone, eliminated. We still have an equal sign. And then right here, what's 10 plus 18? 28. So we combine like terms. Here's what we're left with. 4x equals 28. How would you solve that little equation for x? Divide both sides by 4. X equals 7. 28 divided by 4 is 7. Now, Remember what we found here. We found an x value. We're still dealing with systems of equations. We're still looking for intersection points of a graph, okay? So that 7 is the x-coordinate of your solution. Any questions about where we're at so far? Just like the other day, you guys found one of those components. You found either an x or a y first, and remember how we went to go find the other answer. We took what we found, in this case x equals 7, and now we will be allowed to go back and plug that back in or substitute that back in for an x somewhere. Now, you have a choice. That 7 right there, we can take it there, or we can take it there. It is an x value, so you are allowed to go substitute it back into one of the two original equations for x. It does not matter which one you plug it back into. We just need to choose one and do it. Would you like to take that 7 back to the first equation or the second one? Which one? Second one? Okay, so let's take it back. We're going to take it back, and we're going to put x right there where that x is right next to that 3. So here's what that's going to look like. We're going to go 3 times 7. We're going to substitute the 7 for the x plus y equals 18. We're going to take this 7, we're going to bring it right back here, put it right here for x. We're going to substitute it back in for x in that second equation because now we know what x is equal to. Bless you. 3 times 7 plus y equals 18. Guys, what's 3 times 7? 21 plus y equals 18. How do we get rid of the 21? Agreed. Subtract 21. And what is 18 minus 21? Negative 3. There's your y value. Negative 3. So our solution, the intersection point of these two lines technically, would be at the point 7, negative 3. There's that x and y value that we're looking for that satisfies both equations. Any questions? Now, guys, this was a pretty ideal setup, but guys, that's the first thing I would look for. Do some of your variables cancel right now? Are they identical with opposite signs? Negative y, positive y. Cancel right now. That is pretty ideal. Obviously, that's not going to happen all the time, and that's what we're going to see with these next few examples. Okay, does everybody have everything they need off this screen? $52 more. 52 more days. Okay? Everybody good? All right. Let's take a look at this one. Jot that down. Another system. Take a look at your x's right here. Does 8x minus 3x equal 0? Does it? Makes 5x, right? Take a look at your y's. Does 1y plus 1y equal 0? Yes or no? Yes. What's 1 plus 1? 2. Okay? So right now, neither one of those variable terms, neither the x's or the y's cancel themselves out. Now I want you to look at something. Take a look right here at these y's. They're both 1y and they're both positive. Wouldn't it be nice if one of those y's was negative? If one of those y's was negative, a negative y and a positive y would cancel themselves out. Okay. So here's what you're going to be able to do. The use of multiplication is going to really give you possibilities to do what you need to do. Okay? I can change a positive into a negative by multiplying by a negative 1. Anything, bless you, anything multiplied by negative 1 will change its sign. So, here's what we're going to do. And you can do it to either equation. Okay? And here's the thing. Listen carefully. You can do anything you want to an equation as long as you do it to everything in the equation. You can do whatever you want to an equation as long as you do it to everything in the equation. So, here's what I'm going to do. I'm going to multiply the bottom equation all the way through by negative 1. Okay? The top equation is going to stay the same. The top equation stays the same. The bottom equation, I'm going to multiply this bottom equation by negative 1 all the way through. And I will do that in red here. What's negative 1 times negative 3? Positive 3x. What's negative 1 times positive y? Negative 1y. Negative 1. And what is negative 1 all the way over there times negative 5? Positive 5. Remember, you're multiplying. Multiplying. Guys, you are allowed to manipulate these equations using multiplication and technically division, however you want. Multiplication is going to be kind of the way to go. You want now? How'd you even get that negative 1? I'm choosing to multiply the bottom equation by negative 1 so I can make this y negative. That's what I'm saying. Multiplication is going to give you the possibilities to change whatever you need to change. Okay? And that's what you're going to have to start looking at is how can I use multiplication to change some of these numbers to get what I want? I need a negative y down there to cancel with a positive y. I can change any sign by multiplying by a negative 1. You can do anything you want to an equation as long as you do it to everything in the equation. And that's what I did on the bottom. Everything got multiplied by negative 1. So now watch this. Draw your line. What's 8x plus 3x? 11x. What is positive y minus 1y? That's right, gone. That's what we wanted. We wanted to eliminate the y's here because that was going to be pretty easy. And then what is negative 16 plus 5? Negative 11. Very good. Pardon? There you go. Divide both sides by 11. And negative 11 divided by 11 is negative 1. Very good. There's your x value. Now, where do you want to take the negative 1 and go plug it back in for an x? And again, we can put it there next to the 8. We can put it there next to the negative 3. Or you could put it right there next to this positive 3 now because we kind of created a new equation, so to speak. So really, you have 3 options to take that negative 1 back to. It doesn't matter where you take it. We're going to get the same answer. It's just a matter of what you feel like might be the easiest. Do you want to take it back to 1, 2, or option 3? 1. So let's take this negative 1. We'll go put it right there next to the 8. So we're going to go 8 times negative 1 plus y equals negative 16. Going to substitute it back in. What's 8 times negative 1? Negative 8. Good. So negative 8 plus y equals negative 16. How do we get rid of negative 8? That's negative. So there you go. So add it. So negative 8 plus 8 goes away, right? Opposite of negative 8 is positive 8. So we want to add 8 to both sides. What's negative 16 plus 8? Negative 8. There's your y value. Okay, any questions? I would always check first, does something cancel right now? Like the first problem we did. If it does, awesome. If it doesn't, the next thing I would check is, do I just need to change a sign and then something will cancel like we did here? Multiplying by a negative 1 will allow you to change signs of terms, okay? But those are the first 2 things I would check. Does something cancel now, or can I just change the sign and get it to work? Okay? Those are the first 2 things I'd look for. Those are a couple of the easiest things to do. All right, everybody got what they need on this screen? Okay, let's go to this one. Are your x's going to cancel right now? Does negative 4 plus 1 make 0? Nope. Does 9 and a negative 3 make 0? No. Does not. Okay? Same thing. If I just change a sign, Notice your x's and your y's are not identical. You've got a negative 4 and a positive 1. You got a 9 and a negative 3. So it's going to take more than just changing a sign, okay? So let me ask you this. We've got a negative and a positive x. That's kind of a good thing. We've got a positive and a negative y. That's a good thing. Okay? So here's the thing. Again, think multiplication here. Could you change, wouldn't it be nice if this was a positive 4? If that was a positive 4, wouldn't that cancel with negative 4? What could you multiply times 1 to get a 4? 4. So if we wanted to, we could multiply the bottom equation by 4 and create a 4x there. Here's another thought. That's a 3. That's a negative 3. Wouldn't that be nice if that was a negative 9? Negative 9 and positive 9 would cancel themselves out. What could you multiply times 3 to get a 9? 3. Okay? So again, the use of multiplication allows you to change some of these terms into what you need. Guys, it doesn't matter which one we eliminate first. Do you want to get rid of the x's or the y's first? Doesn't matter. Y's? All right, let's get rid of the y's. So we're going to change this negative 3 into a negative 9. So what we're going to do is we're going to multiply the bottom equation, by positive 3. Sorry about that. We're just going to multiply the bottom equation by positive 3. So the top equation stays the same. Bless you. The bottom equation, we're going to multiply all the way through by positive 3. So 3 times 1x is 3x. 3 times negative 3y is negative 9y. And 3 times negative 6 all the way over here is negative 18. You can do anything you want to an equation as long as you do it to everything in the equation. And we multiplied the whole bottom equation by 3. Draw your line. What's negative 4x plus 3x? Negative 1x. Negative 1x. Remember, you're adding here. You're combining like terms. Okay, so negative 4 plus 3 is negative 1x. 9y minus 9y, gone. That's what we planned for. We eliminated the y's. And what's 9 minus 18? Negative 9, good. So we've got negative 1x equals negative 9. How do we solve? By? Perfect. Divide both sides by negative 1. Negative 9 divided by negative 1, positive 9. And we found an x value, so 9 goes in the front of the ordered pair there. And again, we've got 1, 2, 3 options to put that 9 back into. It doesn't matter which one you go plug it back into. X is equal to 9. We can take that 9 and go replace any x we want with it. Would you like to take it back to the first equation, the second equation, or this third equation that we kind of created? Which one would you like to go back to? It doesn't matter. First one? Let's take it. We'll go put it right there for the first one. Okay? And guys, if you want to do that, if you say, look, I'm always going to put it back in the first one, that's fine. Okay? No big deal. Negative 4 plug in your 9, plus 9y equals 9. Negative 4, plug in your 9, that's why the parentheses are there, plus 9y equals 9. What's negative 4 times 9? Yeah, negative 36 plus 9y equals 9. Next step. Now the 36 is negative. There you go. So add 36. So 9 plus 36, I believe, is 50. No, I'm sorry, 45. Golly. Whew. Boy, it's a Monday, isn't it? I think I'm thinking multiplication. 45. Good, thank you. And then divide both sides by. And 45 divided by 9? Boom, 5. Good. Ordered pair of 9, 5. That would be your intersection point if we were to graph these.
Wait, does that say 90 or 10?
Where at?
There. No?
Oh my God.
Up. There.
That's 9y.
The number below it.
That's a 9.
Oh.
Just a 9. Divide both sides by 9. Sorry. My crappy handwriting. Okay, guys, but again, you may have to create, through multiplication, the term or terms that you need to get something to eliminate. But multiplication is going to give you that opportunity to multiply whatever you need to create what you need. We need to eliminate one of the variables, either x's or y's. Does not matter. I think we got one more. Anybody still need this screen? Okay, keep going. One more. Okay, here we go. Last one. This will be kind of worst case scenario right here, for the most part, for what we're going to do today. So go ahead and jot that down. Worst case scenario here. Do any of the variables cancel right now? Do 3 and 5 make 0? No. Do 2 and 5 make 0? I know, okay? Also notice your x's, both of them are positive. You got 2 positives. The y's, they're both negatives, okay? Again, we need opposite signs. We need a positive and a negative, okay? All right, now watch this. Can you change a 3 into a 5 very easily? Can you multiply 3 times something to make a 5? Not nicely, okay? What about a 2 into a 5? 2 times what is 5? Not very nice, is it? Okay? So, guys, the possibility exists where you might have to multiply both equations to get what you need. So let me ask you this. What would be a number that you could change 3 and 5 into? What would be think about it like a common denominator. What's a number that you could change 3 and 5 into pretty easily?
Can you multiply 5 equals 3J?
15, right? Multiply 3 times 5, that's 15. 5 times 3 is 15. We could change the x's into 15s pretty easily, okay? Look at your y's, 2 and 5. What would be a number that 2 and 5 could change into pretty easily? 10, okay? So we can use multiplication to multiply and get what we need. We've just got to make sure that the numbers are the same and the signs are different, okay? All right, tell you what, for this one, let's eliminate the x's on this one. Just let's find the y first, because I think we found x on all these first. Guys, and again, it doesn't matter. But just for the sake of doing it this time, let's eliminate our x's. So here's what we're going to do. We're going to multiply the top equation by 5. 5 times 3 is going to be positive 15. Now, the 15 on the bottom needs to be negative. What would you multiply times 5 to get a negative 15? Negative 3. Let's multiply the bottom equation by negative 3. And like I said, this is kind of worst case scenario. We've got to multiply both equations by something to get what we need here. So the top equation all the way through by 5. 5 times 3x, 15x. Five times negative 2y, negative 10y. 5 times 2, 10. Guys, make sure you go to the other side of the equal sign. That number gets left alone a lot of times. Okay, make sure you multiply all the way through. Bottom equation, negative 3 times 5x, negative 15x. Remember, we have to create one of these to be negative. Negative 3 times negative 5y, positive 15y. And negative 3 times 10, negative 30. Multiplication gives you the possibility to really create anything that you want. 15 is just the smallest number you could change a 3 and 5 into, okay? I mean, you could have changed those into 30s. You could have changed them into 45s, okay? Probably not going to do that, though, okay? Keep the numbers as small as possible. Draw your line. Do the x's cancel? Yeah, and that's what we wanted. Make sure they cancel. 15x minus 15x does indeed cancel. Boom, gone. What is 15y minus 10y? 5y. And what is 10 minus 30 or negative 30 plus 10? However you want to say it. Negative 20. X's have been eliminated. There's what I have left with y. There's my constant number, negative 20. Divide both sides by 5. What's negative 20 divided by 5? Negative 4. Now, be careful right here. What did you just find, x or y? You found y. Where does that go in that ordered pair? Okay, good. Guys, really watch that because it's real easy to put it up front. And in a multiple choice kind of situation, there's probably going to be a distractor answer with negative 4 up front. Okay? Now remember, this is a y value, therefore you are plugging it back in for a y. So we are looking at 1, 2, really we have 4 options here because we created 2 new equations. I'd probably go back to one of the 2 originals myself. Do you want to take it back to door number 1 or door number 2? 2? So let's take this. We'll put it right there for that y next to that negative 5. So here's what that will look like. 5x minus 5 times -4 equals 10. We're plugging it back in for y, any y. But again, I would try to take it back to what you feel like is easier for you. What's -4 times -5? Positive 20. What's next? Thank you. Subtract 20. Good. 5x equals what? -10. Divide both sides by 5. And x is indeed a -2. Whoops. So -2, -4 is our solution. -2, -4 is our solution. Elimination method. Probably the preferred method, because a lot of times these systems will come to you all lined up pretty nice and neat. X's, Y's, equal signs, constant numbers. Does something cancel right now? Do I need to just change a sign, or do I need to be multiplying by a number or numbers to get what I need? But you are creating, or you need a positive and a negative of the same term to eliminate itself. Okay? But that is the elimination method. Remember Wednesday, warm up, and then a little progress check that will cover substitution method and elimination method. Okay? And then when you get done with that on Wednesday, I would continue to work on anything that you're missing and try to use that time wisely. And then, like I said, Friday will be a regular C day for the most part, and get some stuff made up there. All right. In Canvas, the assignment should be there. I forgot to scan it in right here, but it should be in there. 1 through 7 and then number 10. 1 through 7 and then number 10. Those should be similar as far as setup to what we kind of saw in the examples. Okay? So 1 through 7 and then number 10. But you need to get some reps with it so you kind of get to where you're looking to multiply, looking to manipulate a term or terms to get what you need.